Good morning, students. Welcome to our today's lessons, Qualitative Characteristics of Images Formed by Mirrors and Lenses. And I'm your grade 10 science teacher, Mrs. Mary Joy I. Escamillas. Our most essential learning competency is we will predict the qualitative relationships or characteristics, orientation, type, and magnification of images formed by plane and curved mirror and lenses. Have you noticed how ambulance written in the ambulance car? Or did you ever wonder why is written this way? The word ambulance is written backwards or reverse because so that the driver of any vehicle in its front can instantly read the inverted word in their rear view mirror. Now, let's talk about mirror. Mirror is an object that reflects an image. A mirror is a wave reflector, and its functions use the reflection. It's the bouncing of light rays when it hits a surface like a mirror. We have different types of mirror. We have the first one, the plane mirror, or it is the mirror with flat or reflected surface. This is the mirror we usually use to see ourselves. And we face it every day. A spherical mirror, it is a mirror which has the shape of piece of cut of a spherical surface. We have two types of spherical mirrors. We have the concave and convex. We have different types of. To learn about reflection side of mirror, here are the important terms that need to remember. We have light ray. It is the idealized model of light which is drawn as a straight line. And there are two important rays. The first one is the incident ray, which is represented by I, the ray of light approaching a surface of a mirror. It is represented by an arrow approaching an optical element like mirrors. The other important rays are the reflected ray, which is represent as R, the ray of light in which leave the surface of the mirror. It is represented by an arrow pointing away from the mirror. We also have the normal line, which is represented by N, an imaginary line that can be drawn perpendicular to the surface of a mirror. This is the important rays that you need to remember. We have different types of reflection. We have the specular or the regular reflection, in which this is the reflection of light on smooth surfaces such as mirror or calm body of water. We have the diffuse or regular reflection. This is reflection of light on rough surface such as clothing, paper, wavy, and asphalt roadway. Let's take a look closer where there are specular and diffuse reflection. In specular reflection, the angle of incident ray is equal to the angle of reflected ray. That's why it will give you a clear image of an object. While the diffuse reflection is the angle of incident ray is not equal to the angle of reflected ray. That's why it will give you a blurry image. We have different types of image. It is important for you to know this type of image that form by any optical device such as mirror. So we have the virtual image. It is a virtual image where rays only appear to diverge, and a virtual image is right side up or upright. We have the real image. It is a real image is formed when reflected rays converge in front of the mirror. A real image is inverted or upside down. We have different properties of image formed by plane mirrors. We have the location. It is behind the mirror. And in orientation, it is upright but with lateral inverted or left to right. A plane mirror produces image that has an apparent left to right reversal. Which is the size, its image size or height is the same as the object. The image and object are the same distance from a plane mirror. The image size height is the same as the object size or magnification is equal to 1. We have the type of image. It is virtual image because a plane mirror always forms an upright image, which means it's a virtual image or behind the mirror. What did you observe the image formed by the candle in the mirror? It is in the location of image, same side of the object. Orientation of image, it is upright. Size of image, it is same. And the type of image, it is virtual. We have different types of spherical mirrors. We have the concave mirror or the converging mirror, and we have the convex mirror or the fisheye mirror or the diverging mirror. It has a reflected surface that is curved inward and away from the light of sorts. It reflects light inward to a focal point, and in convex mirror, it is a curved mirror in which the reflected surface bulges towards the light surface. It reflects light outward, therefore they are not used to focus light. Let's have the differences between concave and convex mirror. Concave mirror is also called converging mirror. The image is real, inverted, and bigger, except when the object is between the P and F, where the image is virtual, upright, and bigger. Image is projected on a screen as they are real, while in convex mirror, it is also called diverging mirror. The image form is virtual, upright, and smaller, and the image cannot be projected on a screen as they are virtual. Let's have different characteristic of image formed by curved mirror. Concave mirror is a type of image formed by concave mirrors is depend upon the distance of the object from the mirror, while in convex mirror, the distance of that object from the convex or diverging mirror does not affect the type of image formed. Let's now have the difference between convex and concave mirror. Depends on the qualitative description of an image. Now, what are the different uses of curved mirrors? The common uses of curved mirrors is it is used for shading mirrors or makeup mirror. It is used for concave mirror in astronomical. It is also used in headlights, and it's also used in ophthalmoscope. also used in solar cooker, and it's used by dentist. We can have the common uses of convex mirror. It's used inside buildings for security purposes. And convex mirror used in vehicles to know what is behind the car. And we can use it in convex mirror used in for security purposes, of course. Convex mirrors in an narrow corner of the street. So now let's talk about lenses. Lenses are transparent piece of glass or plastic with at least one curved surface. Well, the most apparent distinction between mirrors and lenses are mirrors reflect light rays. It means that light bounces back, while light rays are refracted pass through a lens. How do lenses work? Lenses work because of refraction. Refraction is the bending of light as it passes from one transparent substance into another. We have different types of lenses. We have the convex lens, which is thicker in the center than the edges, and it's form real images and virtual images depending on the position of the object. And we have the other type, which is the concave lens, which is thicker at the edges and thinner at in the center, and it's form upright, reduced image, and virtual image. We have different characteristics of lenses. We will be familiar with different terms used to describe image formed by lenses. We have the location. It can be behind the lens, it between V and F, between F and 2F, and F at 2 and beyond further than 2F. In front of the lens if the image is virtual. The orientation is upright or inverted. The size is same, reduced or enlarged, and the type of image is real or virtual image. So we have the sample ray diagramming for convex lenses. So if we have the in front of convex lens, we have the orientation behind the lens between F and 2F, inverted with the location, size is reduced, and type of image is real image. While in sample ray diagramming of convex lenses, we have the location of the object is in front of concave lens. So orientation in front of lens or the same side where the object is located. Location is upright, the size is reduced, and the type of image is virtual image. Now let's take a look with the different examples of images at different position of object from the lens. So what are the uses of lenses? We have the common use of lenses in magnifying glass, in LCD projector, in camera lenses, in refracting telescope, and in microscope. Common uses of concave lenses. It is used in blurs, distortion, telescope, and binocular manufacture installed concave lenses in eyepiece so that the person can focus more clearly. And it's also used in CD and DVD players. It's also used in peepholes and also used in flashlight. The most common use of lenses is in our eyes, where the light passes through the front of our eye cornea to the lens so that we can see things. So, I will leave this message to you how we think shows